Section 1.4 covers logarithmic equations. So we're going to start by figuring out what is logarithmic. Logarithmic has this term log, which is typically base 10. And then we're taking x, the log of x, and getting c. We can also see that we can take logarithms of a base other than base 10, and we can indicate that base here. If we see log where there is no base, then that typically means it's a base 10 because we live in a base 10 world. But we also have base b, and comes out to c when we're taking the logarithm of a. Now there's a special one called the natural logarithm. That's indicated by ln, and that is the base e. So when we see natural logarithm, or ln, we're going to think base c, or base e, excuse me. So let's do some equivalent expressions and then we can see how this works. If I want to take the logarithm base 6 of 36 and I get 2, what's the equivalent equation for that? Well, I can just take my base, which is 6, and the 2, which was my answer, and that is equal to 36. And that's how we get an equivalent equation from a logarithm. We have the base, we have the 2 here, so 6 squared we know is in fact 36. What about this one? We have our base, which is 4, to the negative 3 power, so that becomes our exponent, and that is equal to 1 over 64. And we know that from the laws of fractions, that's actually correct. Now let's go the other way. If I have 2 to the 5th equals 32, I want to change this into a logarithmic equation. So how do I do that? Well, it's going to be log base 2 of 32, and that is equal to 5. For this other one, we have log base 10. So we actually don't need to write the 10, but we can write log of 0.0001, and the exponent was a negative 4. And if you put that in your calculator, you'll find out that that's actually the correct answer. So log of 0.0001 is equal to negative 4. How about when we start working with logarithms, we have certain properties that we can use. One of them is if I have two things multiplied together and I want to take the logarithm of them, I'm going to get the logarithm of the first one plus the logarithm of the second one. So log of AB is equal to log of A plus log of B. Same thing with a quotient, because it's the same thing as multiplication. Log of A over B is equal to log A minus log of B. So make sure that we know the difference here. We got a plus sign when it's a product, but a negative sign when it's a quotient. And then if I have an exponent, so a raised to the p power, we're going to take the logarithm of that. We're going to be able to take that exponent and put it out in front of the logarithm. So it becomes p log of a. Some special things that we really want to remember when we're doing this. We have log base 10. Remember that we said if we don't write any base right here, it's going to be base 10. But I have log base 10 of x is equal to x. And so you see the log and the 10 basically wipe each other out. The same is true with the natural log and e, because it is the base is e. So natural log of e to the x power is in fact x. So whatever you have in this exponent, if you take the logarithm of the same base, it doesn't have to just be a 10. If you take that logarithm, you're going to get the exponent back out. Same thing over here is if you take 10 to the log of x, the 10 and the log will effectively wipe each other out, and you'll be left with the x. Same thing with and we raise it to the natural log of x. We're going to get x, because e and the natural log are going to wipe each other out. In fact, that's exactly what happens. So let's do some of these. We're going to simplify these logarithms. So I have e to the natural log of 1/2. Well, remember what we just said. We have e raised to the natural log of x. We're going to get this back out when we do that. So this is just 1/2. How about if we take the logarithm of c d to the e power? Well, now we got to use some more powers here. Well, we're going to use first the product rule here. So we're going to get log c plus log of d to the e power. Let's just make that a little clearer. Well, now we can use the exponent rule, and we're going to get log of c plus e log of d. Seems easy enough. Let's do this one. 10 raised to log ab power. Well, you might think we'd have to do something with this, but in fact, if we did this one, where we take 10 raised to the log of x, in this case, our x is ab, we're just going to get ab out. And so we avoid having to use the product rule of logarithms. How about this last one? We have 2 raised to the natural log of e to the a plus 3 natural log of b to the e. Well, the first one, we notice that we have natural log in e. That just goes away, and we're left with the a. So we have 2a. But over here, we have a natural log of b. It's raised to the e power, so that doesn't work. So we got to deal with that differently. In fact, we're going to use the exponent rule and bring that e out of the natural logarithm. And then we just have natural log of b. And that is it. Now, we can use these rules also to solve these equations, and this is where it's most useful. So let's take log of base 4 of x is equal to 3. Now we're going to convert that using our equivalent expressions. Remember how we did this before. So we're going to have our base is 4. We're going to write the exponent, which is 3. 4 to the third is 64. So x is actually equal to 64. How about this one? Same thing. We're going to take 2 raised to the 5th power is equal to x. Well, that gives us x is equal to 2 to the 5th. If you can't remember them, it's just 2. So 2, 4, 8, 16, 32. So x is equal to 32. Now, let's make it just a little bit harder. We're going to have 2 to the x equals e to the x plus 1. Now, we don't want to just take log here because we have 2 to the x. We can take the natural log, which would make it easier to get rid of the e. So we have natural log. We're going to take natural log of 2 to the x is equal to the natural log of e x plus 1. When we do that, we can take the x and put it out in front of our logarithm on the left side. But natural log of e, those go away, and then we're left with the exponent. That's x plus 1. So now we just have an equation that we have to solve for x. Well, I'm going to need to subtract my x over. So x, natural log of 2, minus x is equal to 1. Let's factor out an x. So we have natural log of 2 minus 1, because we're factoring out an x from itself, still equal to 1. And then just divide what the parentheses has over to the other side, and we get natural log of 2 minus 1 on the denominator and a 1 on top. And that's it. One more to go. Let's take the natural log of both sides. We can take the log too if we wanted to. We would get 2x minus 1 log of 3 is equal to x plus 2, let's put those in parentheses, log of 0.4. Well, now we got to expand some things. We got to expand this. So we have 2x log of 3 minus log of 3. We have x being distributed, so we have x log of 0.4 plus 2 log of 0.4. So now we need to collect our x's to one side and move everything else over to the other side. We have 2x log of 3. We're going to subtract this one. So we have a negative x log of 0.4 is equal to, we're going to add this log of 3 right here over. So we'll have log of 3 plus log 0.4. And let's not forget the 2 that was in front there. And then when we factor out an x, we'll have 2 log of 3 minus log 0.4 plus everything else on the right-hand side that we haven't done anything to. And then we just divide the parentheses over to the other side. So here's my numerator, log 3 plus 2 log of 0.4 divided by the quantity 2 log of 3 minus log of 0.4. That's a pretty long problem. And that's it.